Today I'm going to discuss with you this type 3 of the Lagrange's method of solving a linear partial differential equation Pp plus Q cubed is equal to R. From the Lagrange's auxiliary equation dx by P is equal to dy by Q is equal to dz by R, we may not be able to get two independent solutions by using type 1 and type 2 method. But at least maybe one of the solution we can get by applying type 1 and type 2, but another independent solution cannot be obtained by using that type 1 and type 2. So let us discuss this method here, that is type 3, in order to get another independent solution. Now this is a fraction. dx by p is equal to dy by q is equal to dz by r. Now as you all know that when this particular result of ratio and ratio, then by using componendo and dividendo, we know that each of this fraction dx by p is equal to dy by q is equal to dz by r, it will be equal to this one, p1 dx plus q1 dy plus r1 dz upon p1 p plus q1 q plus r1 r. So by the well-known result of componendo and dividendo, each of this fraction will be equal to this one, p1 dx plus q1 dy plus r1 dz. Here also you multiply by p1 this by q1 and this by r1 and then add. Now where p1, q1, r1 are called multipliers, this can be functions of x, y, z, or it can be constants also. So now here, if the denominator, this one, R1 P1 P plus Q1 Q plus R1 R is equal to 0, that is P1 P plus Q1 Q plus R1 R is equal to 0, then in that case it implies that the numerator P1 dx plus Q1 dy plus R1 dz, this is equal to 0, and then from here you will get one independent solution. You may apply the same, take another P1, P2, Q2, R2 and try to find out that what is that P2, Q2, R2 in such a way that when you apply this method here, then the denominator should be equal to 0. So that the numerator also will be equal to 0 in order to get another independent solution. In some cases, by using this type 3, you may get one independent solution, but the other one you may not get another suitable multipliers to get another independent solution. Then you may try either type 1 or type 2 to get at least one independent solution from the given linear partial differential equation. So let us discuss this method in this problem. Solve z square minus 2yz minus y square into p plus xy plus zx into q is equal to xy minus zx. As usual, what is the Lagrange's auxiliary equation? Capital P is this one, capital Q is a coefficient of small q, and capital R is this term on the right hand side. So the Lagrange's auxiliary equation will be given by this one, dx by capital P is equal to dy by capital Q is equal to dz by capital R. And then you can simplify this one, it will be dx by z square minus twice yz minus y square is equal to dy by x into y plus z is equal to dz by x into y minus z. Now let us find out one independent solution by either using type 1. In this case, from the last two fraction, see, if you consider the last two fraction, x and x can be cancelled. That means this fraction will involve only the y and the z variables. So therefore, from the last two fraction, we have dy by x into y plus z. This is equal to dz by x into y minus z. Now x and x can be cancelled. So now what you'll have here is dy by y plus z is equal to dz by y minus z, where only the y and the z variables are involved. So cross multiply this one, you'll get y minus z dy is equal to y plus z dz. Multiply this one, you'll get y dy minus z dy is equal to y dz plus z dz. Now this one you can easily integrate this one, but now you see that we have z dy and y dz. Transfer this one to this side, then you'll get y dy is equal to set dy plus y d set plus set d set. Now what is this one? Set dy plus y d set is same as the differentiation of the product set into y or y into set. So you can write as y dy is equal to d of y set here. This one is equal to differentiation of y and set plus set d set. And now you see that the variables has been separated. So therefore you can easily integrate this one. You'll get y square by 2 is equal to set y plus set square by 2 plus some constant, say c1, or y square minus 2 set y minus set square, cross multiply this 2, so this will be equal to 2c1. Since 2 is a constant, c1 is a constant, so I can replace it by another constant. So you'll get y square minus 2 set y minus set square is equal to c prime. This will be one independent solution. So to get another independent solution, in this case I have to use a suitable multipliers in order that the denominator, like this one, p1p plus q1q plus r1r will become 0. So I have to take a suitable value multipliers p1, q1 and r1 in order to make the denominator equal to 0. Now let us choose, in this particular case, choose p1 is equal to x. Now what we notice from this equation is that I have set square here, but this one I have minus set here. So in order this set square and this set and this term x set here get cancelled, so I need to multiply this one by set, so that it will become minus x set square, and for this one I have to multiply by x. So, and similarly I have minus y square here. So you'll get xy square. So what this is minus y square. So when multiply this one by x, this one by y, then you'll get xy square, which is plus. So that one and this one will be cancelled. So let us choose p1 is equal to x, q1 is equal to y, r1 is equal to set. Then each of these fraction given in star now. Then each of the fractions, each of the fraction in equation star now is equal to this one. Multiply this one by x, so it will be p1 dx. See, we have to use this one, p1 dx plus q1 dy plus r1 dz by p1p plus q1q plus r1r. So each one of this will be equal now to x dx plus y dy plus set dz. Whole thing divided by, multiply this also denominator of this first fraction by x. So you'll have to multiply it as x into set square minus twice y set minus y square plus yx into y plus set plus, we multiply the last fraction by set, so the denominator also we need to multiply by set. So it is equal to plus set x into y minus set. Let us simplify this one. This is equal to x dx plus y dy plus set dz divided by, now x into set square will get x into minus, it will be minus 2xy set minus xy square plus c yx into y, so it will become xy square plus plus, so it will be y, it will be plus xy set, and then plus set x into y minus set square x. So let us see what are the terms that can be cancelled now. X set square with minus set square x, this can be cancelled. Then minus xy square with plus xy square. Now xy set plus xy set, this will become plus 2xy set, and this will be cancelled with this term. So you see that the denominator now become 0. So this is equal to x dx plus y dy plus set dz divided by 0. If the denominator comes out to be 0, then in that case it means that x dx the numerator plus y dy plus z dz is equal to 0. And what we notice from here is that the x, y, z variable has been separated. Therefore, we can easily integrate this one. And on integrating this one, what we have now is that you'll get x square by 2 plus y square by 2 plus z square by 2 is equal to, say, C3. So finally, we have, or I can write in C2. X square plus y square plus z square is equal to twice C2. Then 2 is a constant, C2 is a constant, so you can replace it by another constant, C2 prime. So this is equation 2. What I have from equation 1 is the value of one independent solution. C prime is equal to this one. And from equation 2, I got another independent solution by using suitable multipliers. Therefore, this 2 will, therefore the general solution will be given by phi of C prime, comma, C2 prime equal to 0. That is phi of, what is C prime? It is y square minus 2yz minus z square, comma, then x square plus y square plus z square equal to 0. So this is the general solution. Now let us solve one more problem so that you'll be more clear with this one. Now solve x plus 2 set into cube, this is P. Plus 4 set x minus y into cube is equal to 2x square plus y. So let us find out what is the auxiliary equation, which is already on the form PP plus capital Q into Q is equal to capital R. So the Lagrange's auxiliary equation will be given by dx by capital P, that is x plus 2 set is equal to dy by 4 set x minus y is equal to d set by r, that is 2x square plus y. Now what we notice from this Lagrange's auxiliary equation, let me name it as equation 1, is that if I consider the first two fraction, then we have the dx differential coefficient here and the dy derivative. Therefore, only dx and dy must be involved, but we have here the z variable also. We cannot eliminate this one. So what we need to do now is, if I take the last two fraction or the first and the last also, it's like that only. When we need only two independent variables, but there will be, the extra variable, that is the x variable or the y variable or the z variable may be involved in that differential equation. So what we need to do now, we'll use this type 3. We'll try to find out a suitable multipliers in order that the denominator will become 0 in order to get two independent solutions. So let us first choose this one. Take P1 is equal to y in this case, cube 1 is equal to x, and R1 is equal to minus 2 set as suitable multipliers. Then in that case, each of the fraction in 1 is equal to this one. It will be y dx plus x dy plus it will be minus 2 set dz divided by x into, it is y into x plus 2 set plus x into 4 set x minus y, then minus 2 set into 2x square plus y. Because by choosing this particular multipliers, we can make the denominator equal to 0, which is equal to y dx plus x dy minus 2 set dz divided by, if you simplify this one, you'll get y set plus 2y set, this one yx, plus 4 set x square minus xy, then minus 2, it will become 2 set into 2x square will become 4 set x square minus 2 set y. So this one and this can be cancelled. Minus xy and yx can be cancelled. 2y set and 2 set y can be cancelled. So which means that the denominator becomes 0 by taking the suitable multipliers. So now if the denominator becomes 0, it means that the numerator also should be 0. X dy minus 2 set d set is equal to 0. Now this set variable has been separated, but we have here y dx plus x dy, and this can be written as d of xy minus 2 set d set is equal to 0. And on integrating this one, you'll get xy minus 2 set square by 2. 2 will be cancelled, so you'll get set square. This will be C1. Name it as equation 2. So we have got one independent solution. Now let us select another set of suitable multipliers in order to obtain another independent solution. Now here what we notice is that I have this one in the denominator as x plus 2 set. Here 4 set x minus y, 2x square plus y. Now if I 4 set x, now if I take minus 2x, or if I take 2x, it will be 2x, then you'll get 2x into 2 set will become 4 set x. So now here this is 4 set x, here also 4 set x. Now I need to take minus 1 as a multiply for this one, so that term will be cancelled. This will become plus y, and then here you'll see that we have this y here also, so this will be cancelled. Then next, because minus into minus will become plus, but this one minus y will be cancelled. Similarly, 2x into x will become 2x square. But here, if I take minus 1, then it will become minus 2x square. So you'll see that the denominator will become 0. By taking another set of multipliers, P2 is equal to 2x, Q2 is equal to minus 1, R2 is equal to minus 1. So by considering this set of multipliers, then each of the fraction in 1 is equal to, it will be P2 dx, that is 2x dx, then plus Q2 dy, but what is Q2? It is minus 1, so it will be minus dy, then R2 is minus 1 plus R2 d set, so it will be minus d set you'll get. And in the denominator also, you multiply this one by 2x first, then it will become 2x into x plus 2 set. Then since I have multiplied this one by minus 1 in the numerator, so denominator also you multiply by minus 1, so it will be minus 4 set x minus y. And here also in the third fraction, I'll use minus 1 as the multiplier. So for both numerator and denominator, you multiply by minus 1. Then the denominator will become minus 2x square plus y. So let us see what will be this one. This will be 2x dx minus dy minus d set. Whole thing divided by 2x into x will become 2x square plus 4x set minus 4 set x, minus into minus will become plus y, and then here I'll get it as minus 2x square, minus into plus will become minus y. Then you'll see that 4x set and 4 set x will be cancelled. 2x square with minus 2x square, y and y will be cancelled. Now the denominator become 0 in this case. So after getting the denominator as 0, then this means that the numerator 2x dx minus dy minus d set also equal to 0. And see, what we notice is that the x variable has been separated, the y variable and the d set variable has been separated. So you can easily integrate this one. What is the integral of 2x dx? It will be 2x square by 2 minus y minus set is equal to, say, c2. 2 can be cancelled. X square minus y minus z is equal to c2, equation 3. So therefore, what will be the solution, general solution? It will be phi of c1 comma c2 is equal to 0. Or phi of, what is c1? c1 is xy minus z square. It will be phi of xy minus z square from equation 2. And from equation 3, what is c2? It is x square minus y minus z equal to 0. I hope it is clear now how to solve a linear partial differential equation. It is of type 3 by the Lagrange's method of multipliers.